KnetMiner at present time provides you with 4 different types of search options. We have keyword search, gene list, genome region, and GWAS peak search. For keyword search, this works a little bit like a Google search. It will catch very widely and not clamp down onto anything specifically. This allows you to find genes which are related to a topic of interest without limiting your search to a specific genome region or list of genes. You're simply limiting it to looking for genes inside of wheat. How this works is it's looking for different evidences with relationships back to your gene, back to genes, and then listing those genes and the evidences related to your keyword search in a table. Gene list search allows you to input a list of genes, of course. So here's an example from the bottom where I'm inputting 20 genes, and you can see these are wheat genes that I've inputted here. And optionally, I've added a keyword filter, seed germination or seed dormancy. So this will now look through the list of 20 genes and find and only return the genes which actually have evidences relating back to one of these two terms. You can use other syntax here. You can also write and I can remove inverted commas. That would then make seed and germination be two different, seed or germination really, be two different search queries. But if I encapsulate those like they were, then we're looking for seed germination specifically. Okay, there's an arrow here at the top where I can collapse this search box. And now I show genome region search. This is a way for you to filter to clamp your search to only specific regions on particular chromosome bands. So when you click the drop down here, it'll show you the chromosomes available inside of the species that you're currently in. I could say between, well, let's try and find a real example here. So here's grain growth, and you entered a start and the end in megabases. It will give you the count of how many genes this is capturing. So 131 here, 110 here. I can change these as well, the color, which is useful for the map view, which we'll get to in the future video. And now I can filter the above regions based on grain fill duration or seed growth, for example. And that will then obviously return significantly less genes than what I'm getting counts for here, because I'm looking for something specific within those regions. And here we go. We found 13 genes with a cross section between our keyword filter and 2 genome regions. Finally, we've got GWAS peak search. Similarly, you can manually add them in as SNPs, where you specify the chromosome that the SNP is on, the nucleotide position, whether your p-value is in standard format or in log10 format, give it a name, and it'll count the number of genes in that region. You can also add more SNPs, or what you can do is import SNPs in bulk. So here I've got a GWAS result file. I'll upload this and make sure that my headers are mapping correctly. So chromosome, position, p-value, mapping to p-value in KnetMiner, SNP. All right, that all looks good. And here I can say, is my p-value in normal format or in log10? I know that it's in normal, so I'll select that one and import this data. Immediately, KnetMiner has told me using a Bonferroni corrected threshold, it has set the p-value threshold to 5.8 log10, and we can see that is still returning 3 total genes in the regions. If I were to change things like perhaps the SNP window region, because what we're doing here is we're creating a upstream and downstream window around each of the SNPs in the file that you've uploaded, and then filtering out the ones that are not meeting a p-value threshold that is initially set by Bonferroni correction, but you can actually come in here and modify. And as I change these sliders, you'll notice that the number of genes in the regions are changing, and perhaps the number of SNPs would change as well, depending on what I change here. Once you're happy with what you're seeing, you can hit search, or you can optionally add a keyword filter. In this case, I can see it's only going to hit up to 8 genes. And so here we go. I've run my search. I see 5 have come through, and you can see the exceptional number of evidence that's coming through for these 5 genes. And that's also largely because we haven't searched with a keyword filter. So if we perhaps have an idea about what this was related to, so I know that this was 1,000 grain weight, I can maybe search here for grain, for example, and that will cut back on the evidence quantities and also help when I go and create the network to focus in on something specific that you as a user have put in.